Hello and welcome to Reduce CO2 Now. In this presentation, we are going to look at global warming and climate change, and especially about where is it going to go. We're looking at scenarios, simulation, carbon budgets, and of course, we are also having a look at the flaws of the Paris Agreement. So before we go into the future and look into scenarios and simulation and so on, we are going to look at the present and facts, because it's really hard to argue with facts. And here you see the entire story in one chart. This is the CO2 in the atmospheres measured from 1960 to 2026. We had a new record of 432 parts per million. And you see the red curve is going up all the time, and it's increasingly going up faster. So this is the amount of fossil fuel emissions. So why the CO2 is rising? It's really simple. We just have to look at this. We are producing more and more CO2 all the time. This is from 1940 onwards, and at least from the 1960s, and you would draw a straight line through the thing, you see it's always going up year for year. There's just this tiny blip in the COVID crisis that it was a little bit lower. Apart from that, the CO2 emissions are increasing all the time. There is no turnaround visible at all. It's just basically a straight line, always more fossil fuel emissions. New record in 2025, 38.1 billion tons. And this is global warming so far. This is here a chart of global mean temperature from 1850 to 1900. That's the reference period. That's where zero line is. And then at least here from the 1960 onward, you see the trend is going up. And you could also argue the trend is going up faster. Nevertheless, in 2024, we had a new record, 1.55 degree global warming already achieved. So really, please remember this, because there are some people who talk in a Paris Agreement that we are going to limit global warming until the end of the century, that in the next 75 years, we will keep it to 1.55 degrees. No way. This is utter nonsense. And, let's have a look at the other things now in the presentation, and will you go and see behind what the people would like to make you think. So these were the facts. Let's have a look at what are the consequences. Well, it's called global warming for a reason. That's why we have, for example, heat waves. Then there's flooding, wildfires, sea level rise because the ice is melting, coral reefs are dying. These are all kinds of observed impacts, especially things like sea level rise is really measurable. And of course, also the heat wave. You just need a temperature and a gauge on how to find out how this is changing. So now we are going into the future. And we had almost for 30 years, we had now climate conferences. And in the climate conferences, the people were talking about CO2 emissions, about climate change and so on. It didn't really make any dent in the development. It's all going straight so far. Yeah? You have seen in the actual facts. But then the people were asking the scientists, okay, make us some scenarios how we are going on. And they call these shared socio-economic pathways, SSPS. So, and they're basically 5 here, what we are going to cover. There's this light blue one, which there's a radical shift immediately to net zero. Yeah, okay. We don't see any evidence that this is actually happening. The dark blue one is, okay, we are going to have a rapid change and immediately a decline here going on, where there is no evidence at all for this. Then there's the amber scenario, SSP 2/4.5. And this is something I call the it's getting better soon scenario. Yeah, it's going to get better soon. Right now, we are still increasing the fossil fuel emissions, but it's going to be better in 10 or 20 years. And then it's going to decline. This is the most favorite scenario for all the politicians, because they can say, doesn't really matter. We are still on this scenario, and in 10, 20 years, it's going to get better. Well, the thing is, are you trusting this? I don't know. But anyway, it's not implausible, because at least this scenario for the short term is assuming that the emissions are rising. Then we have the red scenario, which assumes that it's almost a linear prolongation of the current trend. Yeah? So it's a little bit higher there, but like if you take a straight line, you will see, okay, good. This is a little bit more than extrapolating the current trend. And then we have the dark scenario, the dark red scenario, 8.5, SSP 5/8.5. There we have very high emissions, so the world is ever more producing more fossil fuel emissions. And this is like, you could say, drill baby drill scenario. It's, maybe President Trump's most favorite scenario. So these are just like constructs. It's just like that the scientists need to have something, they need some input data for a scenario to then calculate what's going to happen. And this is basically saying, okay, there's like 5 different scenarios here. And, you and me probably would agree that we are somewhere between the amber and the red so far. Yeah? And the bluish ones are not going to happen. I hope the dark red is not going to happen as well. And we would be somewhere between in the middle of red and amber. Remember, middle of red and amber. And now let's see what's going to happen to the CO2 concentration in the world. So now the input to the whole thing has been how much CO2 is going to get emitted. And the first output of this scenario is actually calculation how much CO2 is going to be in the air. That is not so easy to calculate, but it's at least like, quite straightforward to calculate. So they can do this, the scientists can do that. And they came up, again, you see here the colors. And for the bluish scenarios, you would be at 400 ppm. So that would be like less than we already have, but much more than we started in pre-industrial times. So that's already a risky value, 400 parts per million. But, the dark blue would bring us back to levels of today. Okay, but, these ones are totally unrealistic so far. So forget that. Huh? So the amber one, which is like the one it's going to get better soon, is already bringing us to 600 ppm. A very high level already, 600 parts per million. Oh, yeah, and by the way, it's not ending in the year 2100. We can assume that in the year 2100, we are not at completely net zero. We are still emitting something as humanity. So the values will rise even more. And so the red scenario is going to 850. That's a very, very high value. We're going to see how what these actually mean. This is going to bring the atmosphere of the planet back 30 to 40 million years. We are going to get nearly close to levels that dinosaurs have seen. Yeah? More on this in a later slide. The dark red one is going to get us more than 1,100 ppm. This is definitely dinosaur stage. Yeah? So which one is realistic? Let's just say, okay, we just have seen something between, in the current way we see the world, something between red and amber is realistic. So let's go for something like 700. And by the way, this is also what like the Boston Consulting Room came up with and said, looking at the current trend in world economics, this is what we expect, 700 ppm in the year 2100. And remember, it's not going to stop there because the emissions are still there even in the year 2100. It's going on. Yeah. So this is the CO2 emissions and how much CO2 now we have in the atmosphere in arbitrarily selected the year 2100. So now, how much warmer will it be? Oh, that's a very good question. And the whole thing of these scenarios is that now you're going in much more complex simulations because the scenario is how much CO2 is emitted. Then you are calculating how much CO2 is in the air. That's quite straightforward. Of course, it's not like, simple math, but it's quite straightforward. Now you have to do and predict the temperature on the planet in the year 2100, for example, or in all the times in between. The people are using the scientists are using very sophisticated models, supercomputers, all that kind of stuff. And then they can calculate what kind of temperature will there be. And like the most likely temperature is the one you see the lines. The blue lines, you already learned, forget them. They are not really relevant. And then there's like something between it's probably going to be something between the red and the amber one, hopefully not the upper one. And so if you just mark between there, so we have like, let's say 3.5 degrees. That would be, the outcome of, let's say, the likely scenario, 3.5 degrees. Now you're maybe asking, but what are these shaded areas there? Huh? Okay, very good question. Because there is not, the scientists can't give you one single temperature. That's not how it works. There's always something like a probability to it. You can calculate models, and depending on all kinds of factors, you get a probability distribution for temperature. And if you're not really good in math, it just means, okay, our best guess is that it's like in the middle, of this curve, like the bluish curve. It's the middle. And then there's a possibility that it's a little bit lower. And there's a possibility that it's much higher. Let's say, for example, the reddish area is for 7.0, the red one. And there's like an area below, meaning, it can also become cooler. But there's also a quite good chance that it's not being like 4 degrees, but it can be 5 degrees. So there's always this probability. And when people are talking, they are usually like picking a very nice value. We're going to see that soon in one of the slides. So now there is a big problem here because, the people are always taking like the year 2100 for this. But this is like quite arbitrarily because we're like, okay, it's just a date, year 2100. The real problem is that the CO2 stays in the air for hundreds of years and even millennia. And here you see some curves. You just have to take care that the colors are not corresponding to what we have in because it's taken from a different publication. But it's just telling you, okay, we have like the temperatures going up, and it keeps going up. Even there's like this red line where it's assumed that there's no CO2 coming on top, and that's like the problem. Even if we stop emitting, even if the CO2 levels stay constant, the temperatures are going to go up over hundreds of years. So like even if we stop emitting in the year 2100, it's, there's like here 2 degrees of warming over for the blue curve, and there's 3.5 sort of in the year 2100. So you can roughly double the values from 2100. 2100 is just short term, and it makes it sound nice. We just have like 2 degrees in the year 2100. Yeah, but for future generation, it's going to be 4 degrees. And even if we manage to not put any more CO2 in the air, which again is kind of questionable. But you see, long-term committed, very important point to understand. And one factor which is also measurable, but again, first, you're calculating the temperatures, then you are calculating how much this is going to affect all kinds of ice melting, and then you come to like calculations how the sea level is going to rise. And remember, the bluish scenarios are like really nonsense. So if we like look between the amber and the red one, we are like 0.75 meters, something like in this area. So if you want to buy a house at the beach, you might want to choose one which is like really a little bit higher up on a piece of higher land. Because there's like, again, there are these shaded areas because the scientists can give you like an estimate and a range of where this is likely going to be. So it can also be in the reddish scenario, it could also be a meter. And for the scenario 8.5, where we say there's like lots and lots of emissions, there could be some events like really drastic ice sheet loss and instability, and that would bring us to 1.6 or 1.7 meters. So you want to buy a house on the beach for the kids? Choose an area which is like where the coast is not really that flat. And if you want to look at your beach house, you can have a look at these slides here. That's from an interesting article. if all the ice would melt, hopefully that will at least take 1,000 years or so. But if all the ice would melt, the sea level is going to rise 60 meters. That's like the maximum. It can't really get higher than something like 60 meters. And here you see a simulation of how some countries look like. So Florida, not a great area to live at. And there's a big lake in Australia, of course, the Netherlands, sorry for goodbye, also like the northern part of Germany and other areas which are like quite low, like in the Amazonas area and so on. Better go to some other areas where you can still live and buy a house or a piece of land for your family. Here, by the way, that simulation is quite exact because we can very good predict how much the sea level would rise. The only question is, how long does it take? It's like, is it going to be like 1,000 years or is it going to 2,000 years? It's definitely not going to be anything what you and me are going to expect or going to live into. But, how much the sea level is going to rise in total, that's easy to predict. Now we come another interesting example, and I'm going to use Germany here because I'm living in Germany. I'm a German, so I just take this. But it's quite similar to other countries around the world. And this is a curve taken from the Deutsche Wetterdienst, the German Weather Service, and in our colors is the line of how much Germany has warmed up, and the black curve is global warming. And you see that the global warming is like only half of Germany's warming, or another way around, Germany, land is warming up double the rate as global warming. Why is that? Okay, you're not really interested in the global warming, you are interested in how high the place where you live is. And as the planet is mostly water, it's going to warm up much faster on the land. And that's what we already see. That's what this curve is telling you. So when you hear something like, oh, it's 1.5 degrees, no, it's like nearly 3 degrees in Germany. Yeah. Here, you just have to do this, the zero line in this graph is a little bit different. Here again, an example of Germany, and this is like how much warming we are going to have. And again, until the year 2100 in Germany, you see like actual data until 2024, where this is taken from. The zero curve here is the average value of 1971 to 2000. So again, the zero curve is different. But you will see, the scientists are saying if we have this bluish scenario, which is out of the door, we would have something like warming, something like 1 degree. And you see there now 15% and 85%. This is like the width of this band. They discard the lower 15% of simulation results and they discard the upper 15%. Yeah, so this band is representing like 70% of the results of the simulations. You see all the other slightly in the background. That means like this is like where all the whole range of these scenarios. The same is for the 8.5, which is like the drill baby drill scenario, which is going to give us something like 4 degrees on top of that baseline here. And again, you see there's like the 15% and 85%. So again, when people talk about prediction and values of temperature, it's not really a single value. It's like a range of values. And guess what? The politicians like to use the a value which is like a lower one. Yeah. So they like to talk about the low values because they seem to be nicer. So here you see Germany color-coded the temperatures in the period 1971 to 2000 average, and there's already warming going on. So that has been cooler, in the 1850 to 1900 period, which is like the reference period where we usually measure global warming from. You see then now the predictions, and they are based on the 8.5 scenario. So Germany is becoming really warm. In the year 2100, we are having like average temperatures in Germany of some areas between 13 and 14 degrees. This will bring Germany, we can have palm trees. This is really like Italy then. This is transforming Germany, from what we know, when there's like also snow and stuff, now we're not going to have that much more anymore. We are going to be much more like Italy. And you can imagine what's going, where Italy is then going. They're becoming probably something like, a desert area. But this is like just one example of how such a scenario would play out in temperatures. And again, this is only the central temperature. This is like something like the 50% scenario temperature. It's the middle of the scenario. It's not like there's still the chance that it's even higher. You can put some degrees more for the fact that there are a lot of chances that the whole thing becomes even higher than what is shown here. So I hope your head is already spinning and you love statistics and math and these kind of things. And statistics usually is like the most favorite subject of all university students, right? Okay. This is taken from a very interesting publication. It's for the scenario of 700 parts per million CO2, which is like a very, very likely scenario from where we are going. So that we have in the year 2100, 700 parts per million CO2 in the air. And now is that this chart is really one of the most eye-openers for me in the whole discussion. So let's go over it, what is displayed here. So on the bottom axis, so on the x-axis, you have like 0, 1, 2, 3, 4, 10 until 10 degrees Celsius of warming. Yeah? So this is like global warming. This is not Germany, this is global warming. Yeah? So, and on the vertical axis, you have probability. So this curve is giving you something called the probability density. That means, okay, let's go from left to right. We have now 700 parts per million of CO2 in the air. So we know how much the CO2 came in over the time. We know how much is in the air. Now we can calculate what kind of temperatures do we have. And there's like a 0% chance that there is no warming. That's like completely out of the door. The green curve is at the 0. It's no way. Huh? It's that much CO2. There's like practically no chance in hell that we have zero warming. Okay, that's quite understandable. Now the curve is going up a slight bit, and you have like, let's say, a 1% chance that we get 1 degree of global warming. And remember, we already have 1.55 degrees achieved of global warming. Huh? And so under this scenario here, it's like the probability that we have like 1 degree of global warming is like really, really small. It's something like 1% or so. It's still there, but it's really small. And you see now this curve looks a little bit like a bell curve. You have maybe seen from like statistical things. There's very famous bell curve. The bell curve is symmetric. This is not symmetric. It's skewed to one side. Yeah? On the side with lower temperatures, it's quite short, and then it has a long tail for high temperatures. Okay, so now let's go to 2 degrees. And there we could see, okay, there is something like a 15% chance for 2 degrees. Okay, 2 degrees is more warming than we already have in the world, more than 1.55. So there's a probability for that. And then you go up and you see, okay, let's go to 3 degrees, and you come to something like 30%. Okay, so what this scenario is telling us, that the highest single probability of a temperature is roughly 3 degrees here. And guess what? The people are going, when they talk about this scenario now, they're talking about 3 degree temperature. So when they name this scenario, they will call this a 3 degree warming scenario. Why? Because the single highest probability is with 3 degrees Celsius warming. The only problem is that's not even giving you a 50% chance. It's below 50% here. Because, as you already are like math, you would have to make the integral below the curve, the area below the curve. And you can like easily see that if you take like a 3 degree, the left side, the area there is smaller than on the right side. So That means you don't even, if you take 50-50 chance, it's going to be not 3 degrees, it's a little bit more. Yeah? But the people are going to name this a 3 degree scenario. Why is that? Well, because if you would say, if you want to be 90% sure that it's not going to get warmer than what you have simulated. Yeah? So if you want to say, hey, our simulation show that the maximum, that it's definitely going to be below 6 degrees Celsius. So 90%, in a 90% chance, it's going to be 6 degrees. Huh? But nobody wants to talk about 6 degrees. That's why everybody is saying, oh, 3 degrees sounds much nicer. So the climate scientists, for them, it's the same. The people who know these kind of things, they know, okay, when they take the reference here, when they call this a 3 degree scenario, there is like a very high chance that it's going to be much warmer. The climate scientists understand this. The average person not. They just hear 3 degrees and they think, oh, it's not so bad. But there's this red marked area is that there's like a tail section here. So there's like a 10% chance that it's going to get 6 degrees warmer or more. There's even a chance here for 9 or 10 degrees global warming, which is catastrophic, you know. And in the year 2100, where the oceans haven't really warmed up, that means on land, the warmings will be even higher. So just the summary of the summary is people like to use the like to use much lower values than the ones we are risking at. And it's really the question, would you fly with an aircraft where you have a 50% chance of arriving? That's ridiculous. Even most people won't even enter an aircraft where you have a 90% chance of arriving. The astronauts who were flying to the moon, they were like quite aware that they have something like a 50% chance. These people were taking this risk of dying and like achieving flying to the moon, and they were like expecting something like between a 50 and 90% chance. But no sane person nowadays would fly with an aircraft if they would say, oh, we have like a 50% chance that you arrive, and the other 50%, oh, you die. No, that's not how it works. But this is like it's very, very important part to understand about the simulations. When they talk about a certain value, it's usually just like the 50% value or the single highest value, which is even a lot of times below the 50% probability. So I know that you really love math and statistics so much. I brought you another slide here, and this is showing very colorful. There's like the amount of warming, 1, 2, 3 until 10 degrees Celsius. It's showing the 300 to 1,000 parts per million in the atmosphere. And it's basically like, and then you see there's the 95% line, 90% line, 5% line. And let's say if you are like going up the 2 degrees, and you're going up to the 50 degree curve, and then you go over to the right, horizontally, you will find that with a 95 degree probability, you have practically double the value. And this is how these predictions work. For a climate scientist, it's doesn't really matter. They are saying, oh, in this scenario, I have like 2 degrees warming with 50%, which is totally the same for that person, like 4 degrees with 95% probability, and only a very small chance that it's getting even warmer. But the politicians, they have chosen, let's talk about the 2 degrees. And this is one of the major flaws of the Paris Agreement, because these people are standing there and saying, we are going to take care that we are going to reduce global warming well below 2 degrees. And then they just don't tell you that it's only with 50% chance. Thank you very much for watching. There will be a second video to go on with this topic. And if you want to join us, you find here a link in the description. Join us on Discord and join an online meeting. Thank you very much for watching. Please, let's turn climate change around.